All right, this is the last chapter of grade 10, which is about stoichiometry. Stoichiometry is a way to analyze and compare reactants with reactants and reactants with products in a chemical equation. It is, come on, let's go, computer. It can be classified according to information that is given in the problem and information you're expected to find, which we call the unknown. The given and the unknown could both be reactants, they could both be products, or they could be reactants and products. Masses are expressed in grams, and it is solved by using ratios to convert given quantities by the following methods. There's going to be 4 main problem types that we're going to look at today. Problem type number 1 is that the given and unknown quantities are in amounts in moles. So the general plan for that is the amount of given in moles, and you're going to calculate the amount of unknown in moles. This is going to be done using something called the mole ratio, which I'll talk about. Actually, I might as well talk about it now. Hold on. Let me get Oh, okay, it is kind of next. Hold on. Okay, mole ratio. So, oh, okay, there's L. Where's my cursor? There it is. So we can go from the, let's just say I've got a general equation, A plus B yields C plus D. As long as that equation is balanced, I can go from moles of A to moles of B, or moles of B to C, C to A, B to D, whatever. I can convert between moles of one thing to moles of another thing using a mole ratio as long as the equation is balanced. So the mole ratio is a conversion factor that relates amounts in moles of any 2 substances involved in a chemical reaction. And you get the mole ratio directly from the balanced equation. So for example, if I have, sorry, these are in all caps, they should be lowercase, that's the font. If I have the balanced equation 2Al2O3 yields 4Al plus 3O2, I can come up with, I think 9, no, it has to be an even number. I don't know. I can come up with a lot of mole ratios. So I can have 2 moles of Al2O3. You get them from the coefficients. It's just a ratio between one thing and another. So I can have 2 mole Al2O3 to 4 moles of Al, or you can swap that around depending on if you're given Al2O3 or you're given Al. So you can flip that around. You also have 2 moles of Al2O3 to 3 moles of O2 and vice versa. And you can have 4 moles of Al to 3 moles of O2 or vice versa. So this is for problem type number 1. If you're given, if you're given moles and they want moles. So in the middle, you would use the mole ratio to convert from moles of the given to moles of the unknown. And don't worry, we're going to go through lots of examples. Oh, there's the one. Problem type number 2 is if you are given an amount in moles and you are asked to convert to mass in grams. So what you're going to do here is you're going to have the amount given in moles. You're going to use your mole ratio to convert to the amount of your unknown in moles, and then you're going to use molar mass to change moles into grams. Okay. The next type is if you're given mass and you're asked to find moles. So you're going to go backwards. You're going to use molar mass which is converting grams into moles. So you convert the mass of your given to the moles of your given, and then you use the mole ratio to convert to the amount of unknown in moles. The most complicated type is number 4. If you're given a mass and you're asked to find an unknown in mass, in this example, you're going to use the molar mass of your given to change that into moles of given. Then you're going to use your mole ratio to change from given to unknown. And then you're going to use molar mass of your unknown. And probably it's just easier to show you rather than go through all of these general examples. So we start with a mole ratio, start there, okay? This is why it's super important that all of your equations are balanced. And then you can use the coefficients, which are these numbers in front. These represent the number of moles. So you can say that 2 moles of Al2O3 decompose into 4 moles of Al plus 3 moles of O2. So if I ask you, for example, how many moles of Al are formed from 3 moles of Al2O3. This would be an example of problem type number 1. If you're given moles of, if you're given moles and you're asked to find moles. So you set it up the same way that when we used to do calculations back in chapter 3, when we used molar mass and Avogadro's number, we're going back to that formula, that type of equation. So you write down the number and the unit that you're given. And now it is very, very important that you include the formula because we're going to be converting between substances, not just units. It's going to be unit and substance. And then we're going to multiply that times a mole ratio from our balanced equation. So in this example, I want to have moles of Al2O3 on the bottom of my mole ratio so that I can cancel it. Because what they're asking me to do is they want me to convert moles of Al2O3 into moles of Al. I can do that using a mole ratio like I've got up here. So I'm looking, you don't have to look at all of that. You only have to look at your balanced equation, 2, 4, and 3. So I want moles of Al2O3 on the bottom. I look at Al2O3 and I see a 2 in the front. So that's 2. 2. Sorry, I'm like trying to compete with my marker chooser here. Oh, sorry. Al 2 O. Oh, I almost had it. 3. Okay. Whew. Because on my iPad, I've got I can choose either the laser or the colors of a pen. That little menu bar, like it doesn't go away. And I'm at the bottom of the screen. Anyway, so I've got my 2 moles of Al2O3 kind of based on my balance equation. Now I put on the top the unit they're asking me to convert into, which is moles of Al. Then I look at my balance equation. I see there's a 4. So on top, I do 4 moles of Al. Now I can cut moles of Al2O3, moles of Al2O3, and I end up having 3 times 4 divided by 2. So 3 times 4 is 12, divided by 2 is 6. 6 moles of Al. That's an example of problem type number 1. What if I do problem type number 2, which I believe is you're given the given in moles and the unknown in grams. So let's just go with the same thing. How many grams of Al are formed from, what did I have? 3 whatever, 3 moles Al2O3. It'll give you the general idea. So again, start with the number and the unit with the identification of the substance on the left-hand side. So I'm given 3 moles of Al2O3, leave some space, and then you want grams of Al. That's what they say. How many grams? Grams of Al, that's the unit that they want. So again, when you do chemistry calculations, generally, it's not like physics where you're given a formula like F equals ma, and then you can rearrange the variables to solve for your unknown. Chemistry equation or chemistry calculations, for the most part, are about converting between units and understanding what ratio, what conversion factor you need to change between units. So it's a really, really important skill to have in chemistry to be able to identify, like, over the next 2.5 or now 2 and a little bit years, I'm going to give you like an arsenal of conversion factors that you can use to change between units. So it's important to recognize them when you see them. In the beginning, when we did atoms, I gave you 2 conversion factors. I gave you Avogadro's number, and I gave you molar mass. We're going to be using molar mass again now. Avogadro's number is atoms per mole. Molar mass is grams per mole. And don't forget, mole is abbreviated MOL. Okay. So first thing I need to do is get rid of moles of Al2O3, and I need to introduce aluminum somehow. So I can use a mole ratio to go between these two. So I want moles of Al2O3 in the bottom. The number I get from my balanced equation, it's 2. And I use my mole ratio. I can use moles of aluminum, and I look at my balanced equation, and it's 4. That's exactly what we did in the last question, right? But this one is asking me to find the amount of aluminum in grams. So I can cut. I like to cut as I go, so you can see where you're at now. So I have cut moles of Al2O3, but now I have moles of Al, and I need grams of Al. Well, now I can use molar mass. So I have grams of Al, and it's 1 mole of Al. Well, how do I know how many grams? Oh, I go to the periodic table, and I find aluminium, and I look at, do I have, hold on. I think I have a periodic table on my computer. Do I? Can I look for it? Okay. Happening. Pretty sure I have it somewhere. Do I? Maybe not. Maybe I forgot to download it again. Oh, I don't. All right, I'll have to download that later then. Never mind. Oh, did all my writing went away. Oh, okay. I'll just do it again. Oh. Grams Al. I should have realized from 3 mole Al2O3. So I've got 3 mole Al2O3. That's a 2. Multiplied times the mole ratio, which is 4 moles of Al to 2 moles Al2O3. Sorry about the handwriting. This is why, let me just write it clearer. O3. Okay. This right here is why you now have to include the identification of the substance, because you're changing between products and reactants. Okay, and they want grams of Al. So I've canceled my moles of Al2O3. Now I go to the periodic table. I look at the molar mass. So I find Al, and I see the mass is 26.982. 26.982. That's the molar mass of aluminium. So I can cut moles of Al, and look at that. I'm left with grams, which is what they asked me for. So then I bring out my calculator. I go 3 times 4 divided by 2 times 26.982, and I get 161.89. Okay. What if I say, how many moles of Al from 3 grams? Al2O3. I'm just going through the 4 types of questions, right? So in this case, again, you're going to be using the same conversion factors. It just depends on the order that you use them. This is why I said I'm building an arsenal of conversion factors for you, so that when you're given one unit and they're asking you to convert it to a different unit, you can do a step-by-step, like, what do I have in my arsenal that will allow me to cut the units I don't want and introduce units I do want to get me to the end place. So I start with 3 grams of Al2O3, and I'm over here, I want moles of Al. Well, the first thing, and I still remember my grade 10 chemistry teacher telling me, when you see grams, change grams to moles. And he smacked his hands like that. When you see grams, change grams to moles. Because grams as a conversion factor, or as a, what do you call it? As a unit, you can't compare masses of things, but you can compare moles. So now I have to calculate the mass of Al2O3. How do I do that? I add 2 of Al plus 3 of O. So I already know what aluminium is. So I have 2 times 26.982 plus 3 times 16, which is the mass of oxygen. And what is that? I'm going to take my calculator away. We're going to be doing this all next week, just to let you know. So I've got 2 times 26.982 plus 3 times 16. Oop, that would be the wrong. I accidentally entered 46. 16. And you should get 101.964. That's grams per mole for Al2O3. In this example, I want grams on the bottom. So 1 mole is at the top, and I put 101.964. Now I can cut grams of Al2O3. So now I know where I am. What do I have in my arsenal that I can use if I have moles of Al2O3, but I need to get to moles of Al? I use my mole ratio. Mole ratio allows you to go from moles of A to moles of B. In this case, I want moles of Al2O3 on the bottom, and I look at my balanced equation. I see the mole ratio for that is 2. For aluminium is 4. 4 moles of Al. So I cut Al2O3, and the only unit I'm left with is the one that the question asked me to find. So I go ahead and enter my calculator. 3 divided by 101.964 times 4 divided by 2. Of course, it doesn't matter what order you go in, and you get 0.059. The last type of question, and I'm just going to go with, what was it, 2Al2O3, 4Al plus 3O2. The last type of question is the longest. That is when you're given mass and you're asked to find mass of something else. So again, with the same kind of question, how many grams of Al are formed from 3 grams of Al2O3? So in this case, you start with 3 grams of Al2O3. You want grams of Al. You're going to have to change this grams into moles, use your mole ratio, then use grams per mole of Al. So let's do that. So I multiply times 1 mole Al2O3 over, what was it, 101.964 grams Al2O3, cut. So now I have moles of Al2O3. I use my mole ratio using my coefficients. I've got 2 moles Al2O3, 4 moles of Al, cut. And finally, molar mass of Al, 26.98 grams of Al per 1 mole of Al, cut. I have just enough room for my answer. So whether you go, like my style is just to go one ratio at a time, which is why you might hear me go 3 divided by 101 times 4 divided by 2 times 26.98. If you're more comfortable doing all the top divided by all the bottom, it does not make a difference because of the order of operations. So I just go like one thing at a time, 3, and then I look at this one divided by 101.964, and then go to the next one, times 4 divided by 2, times 4 divided by 2, and go to the next one, times 26.98, and I get 1.59 grams of Al. Is everybody crying yet? Okay. All right. Okay. Let me find. Okay, it's kind of a repeat of what I already did. Right, so here's just another way of looking at it. If you're given the amount of substance in moles and you're asked to find an unknown substance in moles, you just use your mole ratio. I find it, for myself personally, easier to actually do this in practice rather than looking at general plans. Because if you're thinking like given an unknown and moles of unknown over moles of given, that can just get really confusing. So let's just look at an example and do one together. In a spacecraft, the carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide, LiOH, according to the following chemical equation. So there's that equation. How many moles of lithium hydroxide, so this is your unknown, are required to react with 20 moles of CO2, that's your given, the average amount exhaled by a person each day. So again, the main point is that you want to identify what you are given and what your unknown is. Your given goes on the left-hand side, 20 moles of CO2. Your unknown goes on the right-hand side, moles of LiOH. Now, whether you like to use a multiplication here with a separate ratio, or if you like the other style, which is doing it this way, it does not matter. So I'll do this problem using this method. And so if I'm given moles and I'm asked for moles, all I need here is my mole ratio. My mole ratio will be able to convert CO2 into LiOH using my coefficients here. So I want CO2 on the bottom. This is a 1 mole CO2. LiOH is 2. So you cut. Answer is 40. Okay, that's the simplest kind of question. Okay, here's another example. How many moles of sodium will react with water to produce 4 moles of hydrogen in the following reaction? So they've already given you the balanced chemical equation. So again, how many moles of sodium? That's my unknown. And my known, or my given, 4 moles of hydrogen. So I've got 4.0 moles of H2. It's here. So I just need a mole ratio. I need H2 on the bottom. The coefficient here is 1. And I need moles of sodium on the top. That's 2. Cut moles of H2. You get 8.0. 4 times 2. How many moles of lithium chloride will be formed by the reaction of chlorine with 0.046 moles of lithium bromide in the following reaction? Again, they've given you the balanced chemical equation. The first thing that I want you to do always is to make sure the equation is balanced first. How many moles of lithium chloride? That's my unknown. My known, 0.046 moles of lithium bromide. So 0.046 moles, LiBr. What I need is a mole ratio between LiBr and LiCl. I want moles of Br on the bottom. That's why sometimes I use this version instead, because it clearly shows what goes on top and bottom. So I've got 2 moles of LiBr on the bottom. That's from this 2, and 2 moles of LiCl on the top. Cut, and while I'm at it, I might as well cut the 2's as well, 0.046. Okay, what if conversion of amounts in moles to mass? So if, I'm going to skip that part. Let's just do an example. In photosynthesis, something we learned, plants use energy from the sun to produce glucose, C6H12O6, and oxygen from the reaction of carbon dioxide and water. What mass in grams is produced when 3 moles of water react with carbon dioxide? First thing we have to do is write a balanced chemical equation. So it says, plants use energy from the sun to produce, which means they are products, C6H12O6 and oxygen from the reaction of carbon dioxide and water. So we've got water and we've got carbon dioxide. Next, we balance. So I start with assuming that C6H12O6 is 1, and I start with carbon. So I need to put a 6 in front of CO2. Next, I'm going to go to hydrogen because there's only 1 reactant with hydrogen. On the right-hand side, there are 12 hydrogen atoms. On the left-hand side, I need to put a 6 in front of H2O so that H is 12 on the left. The last thing I'm going to do is I'm going to add up all of the oxygen on the left-hand side, and then I'm going to compensate how much more oxygen we need on the right, keeping in mind that there's already 6 in glucose. So I've got 6 times 2 is 12, plus 6 times 1 is 6. That's 18. I already have 6 here. So 18 minus 6 is 12. So I need to put a 6 in front of O2 to balance oxygen. So that's my balanced equation. Now it's asking, what mass in grams is produced? Glucose. Yeah, so it's referring to glucose. So I have grams C6H12O6 when 3 moles of water. So over here, I've got 3.00 moles of water. Pretty long one. All right, first thing I need to do, change moles of water into moles of glucose. So based on my balanced chemical equation, I have 6 moles of water on the bottom, and I have 1 mole of C6H12O6 on the top. So I cut that, And then I have room for my next conversion factor, which is molar mass. So 1 mole, C6H12O6 on the bottom. And now I have to calculate molar mass. So I need 6 times 12.01, which is carbon. What is that? 6 times 12.01. And you get 72.06. Hydrogen, there's 12 of them times 1.01. Is that 12.12? No, 13.01. And oxygen, there are 6 of them, 16 each, 6 times 16, 96. Add all of that up, 96 plus 72.06 plus 13.01, and you get 181.07. So that's 181.07 grams. A lot of times, depending on if you're planning on taking entrance exams and things, there's a few, 3 basically molecules that you, maybe 4, that you want to remember the masses of, so that you don't have to spend time doing that. One of them, of course, is water. That's 18 grams per mole. This is rounded, of course. Another one is CO2. That's 44 grams per mole. This one, glucose, they round that to 180 grams per mole. And the other one is sucrose, which I think, don't quote me on this, I think is 340. Let me just calculate that real quick. But these are, it's good to know to like save time if you're taking entrance exams. So let's see, C12, so 12 times 12.0, 12 times 12 plus, was it H22 plus 011, 342, yeah, so 340. Haha, I remembered. Okay, so that's just as like a timeout pause, like FYI. Those 4 amounts are good to know. So if I'm doing mental math, it's always good to practice mental math. I see 3 divided by 6. I'm going to cut that down to a 2. I'm going to round that to 180, and 180 divided by 2 is around 90. So again, rounding is your friend for multiple choice tests, because you're going to be able to eliminate possibilities, and you'll be able to choose the number which is close to what you rounded off. It's not going to be exactly, but close to. And notice I changed my equal sign to approximately because I rounded. I have 10 minutes, but I'm supposed to, all right, let's just do practice with this one. I'll continue with the second 2 types on Monday. So I just want to practice more of this type. Phosphorus burns in air. So phosphorus burns in air means combustion to produce a phosphorus oxide in the following reaction. All right, I gave it to you already, so never mind. Great. All right. What mass of phosphorus will be needed to produce 3.25 moles of P4O10? So what mass of phosphorus? And I've got 3.25 mole P4O10. So again, first thing, your mole ratio. I want to change P4O10 to P. So according to my balanced chemical equation, it's 1 mole of P4O10 per 4 moles of P. So I cut P4O10 out. And now I just need the molar mass of phosphorus. So 1 mole of P, looking at my periodic table, it is 30.974 grams of P. Cut P. And now I use my calculator. 3.25 times 4 times 30.974 equals 402.662. You could do 402.7, I suppose, grams. So everything is cut except for the unit that they're asking you to find. Yeah, 403, even rounded even more. Okay, hydrogen peroxide breaks down, releasing oxygen in the following reaction. So we've got 2 hydrogen peroxide breaks down to 2 moles of water plus 1 mole of oxygen. What mass of oxygen is produced when 1.84 moles of hydrogen peroxide decompose? So I've got grams of O2. Don't forget, oxygen is a diatomic molecule. I've got 1.840 mole of H2O2. First thing I want to do, change moles of H2O2 to moles of O2. So according to my balanced equation, 2 moles of H2O2, 1 mole of O2. So H2O2 cuts. And then I do the molar mass of O2. 1 mole of O2. Now, this is where I want you to be careful, because on the periodic table, you look at oxygen 15.999, but the formula is not O, it's O2. So 16 times 2, 32 grams. So if I was doing this on a multiple choice test, I would look at 1.84 and look at this 2 down here and say, this is close enough to 2 that I'll just assume, excuse me, they cancel each other out. I'm looking for an answer around 32. But if you think about the relationship between 1.84 over 2, that's going to be less than 1, right? So you're going to look for a number that's slightly less than 32. Whatever one of the choices is slightly less than 32. But for my test, you get to use a calculator. 1.84 divided by 2 times 32. Yeah, 29.44. But for multiple choice tests, especially if you don't get to use a calculator, it's really important that you round and use your ThinkMeet. 29.44. All right, I'm gonna stop there because